everyone. This is Anthony Silva here. We're back for another problem walkthrough on Leetcode for our Leetcode 150 walkthrough that we're doing. So nearing the end of the arrays and hashing set for the Leetcode 150 problems. We think we got 3 problems left after this one, so we're just going to keep chugging along, and hopefully we'll be able to get to the end of this problem set pretty soon. All right, so let's take a look at our problem statement here. So product of array except self. All right, so given an integer array nums, return an array answer such that an answer at index I is equal to the product of all the elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. All right. So you can just use regular ints if you're using like static type, but keep in mind you might want to use longs if you will, for example, need to use like 64-bit integers. So keep that in mind in case there is this slight change. There is a slight change from 32 to 64-bit. There's a catch. You must write an algorithm that runs in O of n time and without using the division operation. All right. So example 1. We have 1, 2, 3, and 4. So what I can tell you is that if you actually multiply all 4 of these numbers together, you would actually get 24 here. And then notice that we can actually divide 24 by each of these elements to get the elements in our output array. However, we were just told that we cannot use the division operation here, so we are unfortunately not allowed to use it. So we're gonna have to come up with another trick here. We could use like prefix and postfix. It's not some products here that we could use to solve this problem, but for the sake of talking about multiple solutions that we could try to implement. Let's start with the obvious solution, which is actually the brute force solution. All right, so that would mean we would have to start at index I, check every single in each iteration of a for loop, do another for loop where we check every index except I, and get multiply those numbers together to get the product, and then store it in an array. All right, so let's start with an empty result array. All right, and we're going to loop through the array. The nums array. We'll use index I. And then in this for loop, we want to set our product value equal to 1. So this is just going to be our default like product value throughout each iteration. So we and then we would add this product value to our result array here. So product equals 1. We got to loop through the nums array again. We will use index j. And then we just want to multiply this by nums at index j, except when we reach the instance where I equals j. So we want to check that before completing another step. So if I does not equal j, we'll add another step here. We would have to multiply product by nums at index j. All right. And then step 7 would be to run through the entire loop and then append product to the result array. And then return the result. All right. Pretty simple solution, but we do have to acknowledge that this is a pretty poor time complexity here. So it's an O of n time complexity. So we could definitely improve this solution a little bit better. But that's where like the prefix and postfix products come in. So I'm going to show you what that looks like, right? So we're going to start off with our result array. But instead of having it empty right off the bat, we can actually repopulate it with ones. I will get to why we are doing this in just a second. But anyways, we can use a for loop to loop through nums. We'll use index I. Real quickly, we start at index 1, not 0. So what we're going to do in this for loop is actually calculate our prefix product values. So what we're going to do here is actually, so we would start out with imagine that this is our output array that we're going to try to output later. So we want to start at index 1 because we want to multiply this by whatever is here, and then add that to our resultant array. What this is going to do is simply add the product of the numbers in nums up to index I. So in this case, it would be 1 to start here. Then we multiply by 2 to get 2. Multiply by 3 to get 8. No, check that. 6. Sorry about that. And then multiply by 4 to get 24. All right, so that's what a prefix product is. You keep on loop through the array and then store the products as you move forward in the array. So we'll call result I equals whatever you use from the previous index times our nums array. All right. Now we're going to start with the postfix value. So we're going to do another for loop, but it's going to be a little bit different this time. See, what we're going to do here is we're actually going to go kind of loop backwards in the array. So we're going to use index I, start at last index, go all the way to index 0, and decrement by 1. All right, so this is where we're actually, so this is going to be where we're gonna create our final product here. So we're going to do result I times equals Hey, get out of here, stupid ass. It will be result I equal it will be whatever it is times our postfix value, and then we will postfix times equals nums I. All right, so similar to how we were getting prefix products by looping through the array from left to right, we're actually getting postfix products by looping the array from right to left. All right, and then right, and then we use this to to append the products of every element except the one at index I, then we return the results array. So allow me to show you a little bit better what this really looks like. All right, so let's start off with our first example here, which is 1, 2, 3, 4. Okay. So this is going to be what our prefix array is going to look like. We start at 1, then we multiply by 2, multiply by 3, and multiply by 4. All right. So we're just multiplying elements from left to right. And then the postfix array is going to be the opposite, really. So we start at the right index, and then we multiply by the previous element, then the previous element, then the previous element. Okay? Now, what we're going to do, actually, is... so what we're doing is using this information, nation, to determine what the resultant array is, basically. So first off, we want to store the results of running this code. So we start off by taking the prefix of 1, which is basically what's 1, which is non-existent actually. So we take the last element instead, basically. So divided by 1, divided by the first element. All right. For the second one, we want everything but we want 24 divided by 2, which is 12, basically. So then we got 12 right here. Then we had 24 and 6. No. All right, so 24 and 3 should give us 8. And then 24 and 4 divided by 4 is 6. So, and then that's our prefix right here. All right. That was probably not a really good explanation, but hopefully it makes a little bit of sense. But we're going to try to implement our code here. So let's start off with empty results with a result array. This is not really empty. We're going to do as many numbers as we need based on the length of our nums array, which is our input. And I'm going to start with our initial for loop. We start at index 1, go up to the length of nums. Go up to the last element. All right. We're gonna do this magic. Okay, so maybe I've made a little bit of a mistake with trying to implement the description here. So this is actually index 1 prefix. So we're going to have 1, 1, which is our index 0 here, by default. Multiply that by 2. No, by 1, because that's I minus 1. Okay? Now, then for index 2, we take what we had from here, multiply this by 2, get 2. All right? And then this would be 2 times 3. So the number is index 2. So that's 6. All right. So that's what this step does here. But instead of getting an array, building up another array, we're actually just keeping our resultant array as our prefix array, and then we edit it with a postfix array sort of deal in this next step we're going to implement here. So we're going to do postfix equals 1. Now we got to loop through nums one more time, but we start at the last element. Make sure you put the -1 here. Go down to -1, which is basically the element before index 0. And let me decrement by 1 every time. All right. So result I multiply by our postfix. So in this case, it would have to be 6 times 1, which since that's our initial postfix value right here. We change our postfix x to relate to nums I. All right, and then we continue working backwards. Backwards as follows. So now we have this. Yes. Sorry. So we have 6. We should simply move down here. We move our set our postfix value to 4. Then we multiply our prefix value by that to get 8. This is our new postfix value here. So now we move on to correction. Postfix is supposed to be 3. And then all right. This does not work well. Well, I probably could have given a better explanation for this, but I apologize in advance. But you know, sometimes I can't understand everything. I'm saying that right, but this does work. I do know that. So as long as I didn't make any errors here. So let's try and run this. Okay. So I did mess something up. All right. Let's see. Where did I go wrong? Okay. One more time. All right. So we have our initialize array of ones. If it was zeros, we get zero products all the time, and that wouldn't work, right? Result I equals result I minus 1 times. I see what I did wrong. Gotcha. So it was the nums, not result. There, now it works. So we submit this, and boom, it worked just fine. All right. Yeah. Again, sorry that this did not quite work as I hoped it would. But I will try to do better in future videos that where I try to do coding problems such as this. But anyways, we solved it. Got this out again, and it kind of involves the idea of using prefix and postfix sums, but instead of using arrays, we're actually calculating the result as results in our resultant array. So, which kind of explains the follow-up here, actually, where it asks us to solve the problem of one extra space complexity. So we just have this one resultant array in our code, and that's it. So, really, our tiny complexity here is going to be an O(n) solution, just like we were asked to do. And our space complexity is, thankfully, O(1). Very convenient. Whoops. All right. Anyways, that's it for today, guys. Thanks so much for watching. Be sure to subscribe to my channel for more updates to my channel. Hopefully, I'm planning to start the September Leetcoding challenge pretty soon. It's August 28th as of today, so I will definitely try to get started on when's the first? Okay, so for about 4 days from now. So we'll definitely get started pretty quickly. And almost forgot. Don't forget to check out the C++ and Java solutions in the comment section below this video, in case you want to see this in a different solution in a different language. All right. So again, thanks so much for watching. So long.